Good morning, everybody. So, as we know now, till now, you people are saying that solving the mole concept for solid substances. So, that is what we always will take either a given mass, or they will say given particles, or number of particles, or number of atoms, and etc. So now, if they have given the mass and or they have given the particles, as we all knows that number of moles n is equals to formula is given mass divided by molar mass. And if they have given the particles, what is the formula, everyone? Number of moles is equals to given number of particles divided by Avogadro number. Is it right or wrong? Yes or no? So if they are giving the mass like this and given the moles like this. Now, the most important thing I'm going to say you today that will help you in so many places. All of you remember, wherever in the future in chemistry, it will surely will help you in definitely. That is what mole concept for gaseous system. Please keep it in mole concept for general awareness also. This is a question. Basically, what is the 1 mole of gas? Like, what is the volume of 1 mole of gas? They will ask you, like at the STP, standard temperature and pressure. That is a more popular question in government exams and now. Mole concept for gaseous system. Okay, now let us discuss about it. Now, if you take here, so if you take any 1 mole of any kind of gas, if you have taken under standard conditions of temperature and pressure, do you understand what I'm saying? Under standard, that is what STP will say, standard conditions of temperature and pressure, okay, means T is equals to 0 degrees Celsius and P is equals to 1 atm. What do you mean by 1 atm? Anybody? What do you mean by 1 atm?
Atomic pressure.
Atmospheric pressure. Understand, Hari? 1 atm means atmospheric pressure. Please remember 1 atm. Always like these concepts only will make you always different from your friends. That is what I will say. You always focus on the things. Okay. So now Avogadro number of molecules. If we take under standard conditions of temperature and pressure, Avogadro's number of molecules. What do you mean by Avogadro number? Anyone? Yes, please. What do you mean by Avogadro's? Avogadro's number
6.022 into 10 power 23.
Yes, 0.22 into 10 power 23. Avogadro number of molecules of any gas occupies the same volume which is equal to 22.4 liters. You understand, Mitakshri? Or else we will say 22,400 milliliters. Anybody is having any doubt, you can ask. So if we take at normal temperature and pressure, at standard temperature and pressure, be 0 degrees Celsius and 1 atmospheric pressure, if we take any gas of Avogadro number of particles, definitely it will occupy how much volume, Hari? It will always occupy 22.4 liters. Understand? And if you take this volume is only known as molar volume, or we will say gram molecular volume. But before, when we are solving mole concept, what is this called as capital M? Anybody can tell? Capital M is called as what? Molar
Molar mass, sir.
molar mass. Now this one, what we are saying? Molar. Yes, please, Hari. This is volume. So that is why what we are saying. This volume is known as, what is to call Mithakshri? Molar volume. Okay? Or we will say gram, their gram molecular mass. So here we will say gram molecular what? Volume.
Volume.
That is what you have to remember. So, if you take any gas which is having Avogadro number of particle at STP, then which will occupy how much volume? Everybody, open your mouth. Very, very important. How much volume it will occupy? Yes, please. It will occupy the
22.
22.4 liters volume. Very, very important in our daily exams and all. What is the volume of a gas of 1 mole of a substance or Avogadro number of particle? Now, which is equals to how many moles, Harish, Amitakshri, Aviram, anybody can answer. Akilan, which is equals to how many moles? So, I am taking that Avogadro number of particles. Observe very carefully. As we know, Avogadro number of particles or Avogadro number of molecule. Number of molecules, I'm saying that which is equals to any substance which is equals to 22.4 liters of volume. Do you understand? So now which is equals to how many moles, guys? Anybody can tell? Which is equals to 1 mole.
1 mole.
Very good. That is what you have to remember. Do you understand, all of you? Now, that is why we can say amount of the substance which has equal to 22,400 ml or 22.4 liters at STP. What do you mean by STP? Standard conditions of temperature and pressure. Then that is only equals to mole of a gaseous substance. That is what you have to remember. Do you understand, everyone? So please write that. We can say that, therefore, we can say that the amount of the substance which has volume equal to 22.4 liters at STP. STP means what? Standard temperature and pressure. STP conditions is known as a mole of gaseous substance. Mole of a gaseous substance. Do you understand? Yes, Akilan, Imish.
Yes.
That is what you have to remember. Now tell me, suppose for example, I have given 1 mole of SO2 gas, 1 mole of SO2, sulfur dioxide gas. Now tell me which is equals to how many liters? It will occupy how many liters at standard STP? Everyone?
22.4 liters, sir.
Yes, which will give you 22.4 liters, understanding, of SO2 molecules at what temperatures? STPs, yes, standard temperature and pressure, which is equals to how many particles? Any girls? which is equals to how many particles? 1 mole of
Zero.
Avogadro number
Avogadro number.
6.022 into 10 power 23 SO2 molecules. Is it okay, Mitakshri? Abhirami? That is what you have to remember.
Yes, sir.
Understand? Next. Suppose I have given 1 mole of NH3 gas. Mr. Aswin Balaji, tell me. 1 mole of NH3. NH3 means what? Ammonia gas. Tell me which is equals to how many liters? Arun Kailash? Which is equals to how many liters? Kaushik, Gokul, which is equals to how many liters? Again, how many liters? 22.4 liters of ammonia gas at what? At ST. Okay, so which is equals to, again, how many particles? 6.022 into 10 power 23 ammonia molecules. Is it okay, everybody? Abhirami? Clear? That is what you have to remember. Nimish, Noor. Okay. Now, from this, if they will ask you in an exam, suppose not in this, I'm saying, generally like any small Olympiads and all. So, you can convert volume and number of moles very simple. So, let us take now, if you'll observe, how to find the relationship between these volumes and as well as. Okay. Now, same way, you can take another two circle. So now, how to find the relationship between these? Now you can see all of you. So one thing, you take it as a volume of a gas, volume of a gas in liters. At where, guys? At STP. Okay, Harish. Next, number of moles. Number of moles. Now, if you want to find the conversion number of moles into this one and like this, if you want to do, just we have to convert it into like this. You can see, if I want to convert, okay, volume into moles, I'm saying you can see, sorry, I can draw normal. Okay, so now if you have taken, I want to convert volume into number of moles. Okay, just divide by something. Anybody can tell what is that? Harish? 22.4 liters. If I want to get number of moles into volume, just what we have to do, guys? Multiply by 22.4 liters. That's how it is. So please make it. You have to remember this. Everyone. Mr. Haris Eras, good morning.
Yes, sir. Good morning, sir.
Late again. So remember, just nothing I taught. If you take gas, if you take any 1 mole of gas, definitely it will occupy 22.4 liters of volume at STP. STP means standard conditions of temperature and pressure. Means at 0 degrees Celsius, 1 atmospheric pressure, 1 mole of any gas will occupies 22.4 liters volume, which is equals to Avogadro's number. So that is what mole concept for gaseous system. That is what I taught. But do yesterday previous concept, mole concepts and all you not attended. Have you watched it? You have to complete the Harish. Okay.
Yes, sir.
Yeah. So that is what it is. So finally, you have to remember, if they will ask you 1 mole of any gas will occupy how much volume, guys? All of you. 1 mole of any gas will occupy how much volume? 22.4 liters at STP. That is what you have to remember. So complete it fast till here. Clear? Anything doubt? Anyone can ask. Complete till here, then we'll proceed. Clear, right? Shall we start now? No. Let it be once again I'm saying, remember, as we know that if the number of particles are too long, like number count is very, very big, we people cannot count by numbers. Suppose if I have given you 1 gram of hydrogen gas, understanding? Hydrogen gas, if I have taken, which contains 6.022 into 10 power 22 hydrogen molecules. Do you understand, Harish? So that is why if you take any kind of particles, like these atoms inside a particle matter is extremely small, which is not possible to count. So that is why what we are doing, we are using a concept to measure the amount of substance is only called as mole concept. So with the help of mole concept, we can measure how much of quantity has been given easily. So that is only we will say mole concept. So this mole concept, as I told you, if they will give you mass, for example, I have given you 32 grams of ammonia contains how many moles or how many particles, they will ask you. So we people cannot count by normal with the fingers 1, 2, 3, 4, 5, 6 and all. So what we will do, they are giving you the mass. That is what given mass. Mass is given. So immediately we'll find the molar mass. So molar mass means what? Atomic mass writing in the grams. So if we take ammonia, number of atoms of first element 1 into atomic mass of first element. What is atomic mass of first element? Nitrogen, everybody?
14, sir.
14.
Understanding? Plus number of atoms of second element. How many are there? 3
sir.
into what is atomic mass of hydrogen? 1.
1, sir.
It is equals to 14 into 1, 14 plus 3 into 1, 3, which is equals to how much? 17U. But this is molecular mass. But what we want? What do we want, Harish? Gokul? Molar mass.
Molar mass.
Molar mass. So writing U in place of U, if I'll write gram per mole, that is what we used to say molar mass. Understand, Harish Eras? Or we will say
Sir.
molar, understanding? Molar, what will say that? Everybody, gram molecular mass. That is what you have to remember. Gram molecular mass, or we will say molar mass, which is equals to 17 gram per mole. So like this, we will find the molar mass first, and later we will find number of moles. So number of moles is equals to, we are having two formulas. One is given mass divided by molar mass, or second formula, given number of particles divided by Avogadro number. So what is Avogadro number? N Avogadro number is equals to what? 6.022 into 10 power 23 particles. That is what you have to remember. Okay. Now, as I told you, with the help of formula, everybody can solve, but without formula, very few only can solve. So that is what we are going to discuss in our today's class. So now let us see how to do, okay, how to do the numericals of mole concept without formula. Shall we start now?
Yes, sir.
Yeah. Now, so please all of you remember, without formula, if you want to solve these numericals, first is the thing you have to remember three things. Okay, so let us see the three formulas. Everybody should remember. I will say you. So after that, when you are solving, you will experience that. That is what we will say, like in engineering method. We will say. Okay, so please keep adding mole calculations. Okay, mole calculations using the unit analysis method. What method this is, Harish? Unit analysis method. Mole calculations. Mole calculations by using unit analysis method. Okay, definitely you'll feel a new experience with this, but this is what where you no need to remember any formula even to solve the numericals. Okay, so now the first step in this, all of you remember, write down the unit requested. Please write it for step one. Totally how many steps I told? Totally steps. Okay, step one it is. So steps is totally three steps. Okay, steps. Step one, write first, write down the unit requested. Write down the unit requested. I'm requesting you all to stay till last today at least. You'll learn definitely one new thing. Write down the unit requested. Second one, Divya, good morning. Second one, write down the given value. Write down the given value. Next, third one, apply unit factors. Apply unit factors. Apply unit factor or as factors to convert the given unit to convert the given unit. Even gases also we can solve, guys. Harish, are you listening? Just you write it, you'll feel it without formula also you can solve it. How it will be, you'll experience. Given units to the desired units. Given units to the desired units. These are the three steps you have to follow, but you will read the steps, something will be confusing, but when we are solving, it will be very, very easy. Okay, so let us see that. We will make it. So let's start now, all of you.
Yes, sir.
Yeah. So now this is the most important in high, like how high grade we will be feel like how much it is important. You will understand how fast and how you can do it. Okay. So let us write the first question. With the question you will solve. Okay. Even for this with the steps also I will say you later you will understand it. Write it now. How many sodium atoms are in? How many sodium atoms are in? First question, guys. How many sodium atoms? How many sodium atoms? Sodium. Sodium means what is the symbol? Gokul, Akilan. Sodium means Na. Okay. Sodium atoms are in 0.120 mole, 0.120 mole of Na. Na means what? Sodium. Okay. So now what they are asking, Harish, exactly can you tell me? Anybody? Everybody read and tell me what is the question they are asking. They are asking how
To
many
find.
sodium atoms. Means what they are asking, Mitakshri?
Number of particles.
Number of particles, very good. So now basically if we'll do this one, as we know that directly we can solve with the help of second formula, that is what number of moles is equals to Avogadro, given number of particles divided by Avogadro number. Now we are solving like we want this one, so that we'll multiply number of moles into Avogadro number, we'll get the answer. Is it yes or no? Yes. So then suppose I don't know the formula, then how to solve? Very simple. So three steps I will say. What is the first step? Stepwise you can see. Read the step. Now this question might be you will feel easy, but later you can see the difference. First one, write down the unit requested. What is the unit they requested? Check it everybody. What is the unit they requested? All of you. What they have given? We want atoms of sodium. Is it yes or no? Please respond. Yes?
Yes, sir.
Write it. We want atoms of sodium. Unit requested. We want atoms of sodium. That is the first unit requested. Final clear? This is what our aim. Is it yes or no? Gokul. Second one, we have how much? What they have given? What is the second step? Read everybody, second step. Write down the given value. What is the given value? Yes, tell me.
Number of moles.
Number of moles. We have, write it. We have 0.120 moles of sodium. For first one or two questions only, you'll write this one. Later is not needed. Understand? For your experience, I'm saying. Next. What they are asking, apply unit factors to convert the given units to the desired unit. What is the unit factor? Anybody can tell here? What is the unit factor? I will say. They have given moles and they are asking particles. So we know 1 mole of any substance which is equals to something. Anybody can tell? 1 mole of any substance. They are giving moles and they are asking number of particles. So what is the 1 mole of any substance? What we can say that? Which is equals how many particles? All of you.
Avogadro number.
That is your right. 1 mole of sodium atoms is equals to 6.022 into 10 power 23. 10 power 23 atoms of sodium. Are you clear now? Harish? Harish Eras? That is what you have to remember. Are you
Yes,
clear?
sir.
Now you can see how I will solve without formula. So all of you observe very carefully. Now first given, what is the given thing? 0.120 moles of sodium. Is it yes or no, Mitakshri? Yes? Bar.
Yes, sir.
Draw the bar line. Now you can see. So the given moles is 0.120 moles of sodium. But we know 1 mole of any substance which is equals to how many particles? How many particles? Suppose if I'll take 1 mole of sodium which is equals to how many particles? All of you. Which contains what? 6.022 into 10 power 23 atoms of sodium. Is it yes or no, Mitakshri? Harish?
Yes, sir.
Yes.
Yes, sir.
That is what I'm saying. Nothing I'm doing. See here. 1 mole of sodium is equals to Avogadro number of sodium atoms. That's all. Now here, mole of sodium and moles of sodium will get cancelled. So what is remaining? 0.120 into 6.022 into 10 power 23 atoms of sodium. So if you multiply this one, everybody multiply and tell me how much it will come. Google 0.120 into 6.022. Multiply it and tell me. Yes, please. 0.120 into 6.022. How much are it?
So it is 0.7.
Yes, 0.722 into 10 power 23 will come. Now let us modify this one as, can I write as a 7.22 into 10 power 22 atoms of sodium. Is it right or wrong? Anybody having any problem? Clear? Any doubt? Anyone? Please let me know. Understand now? Yes, please. Any doubt? 0.722 I written as a 7.22 into 10 power 22. Are you clear? Divya, Danishka? That is what it is. So this is the question. Any doubt in this? Ask me. If you are okay, then you can do it. Any doubt? Harish Jaras? Harish?
No, sir.
Solid. Please stay till last. Today you'll definitely will feel something. Okay. If is it completed, then I will give the next question. Shall we go for the next question?
Yes, sir.
Right. How many moles of potassium are in? How many moles of potassium are in? This question you have to write 3 steps. You have to tell me first. Later only I'll say how many moles of potassium. How many moles of potassium? It will make you always difference from everybody's. Potassium means what is the symbol? Everybody. K or in 1.25 into 10 power 21 atoms. 1.25 into 10 power 21 atoms of K. That is the question. So now, first three you are having three steps. One by one step. Tell me, everybody. This is the question. So first step I want. First step 1. Everybody. Step 1.
So we want moles of potassium.
What we want, that is, we want what? Everybody.
Potassium.
Moles of potassium.
Moles of potassium. Very good. Step 2, given. What is given? We have
So
what?
we have
1.25 into 10 power 21 atom of potassium.
1.25 into 10 power 21 atoms. Mr. Aswin Balaji, remembering only you can answer. Speaking, you have to speak. Now third one, factor supply. We know that again. Mole and atoms. What is the relation? Mole and atoms. What? What is the relation? 1 mole of any substance equals how much?
Avogadro number.
That's all. So 1 mole of potassium is equals to how many particles? 6.022 into 10 power 3 atoms of K. Is it S? Everybody? Clear? Yes or no?
Yes, sir.
Now, write given one first. What they have given? 1.25 into 10 power 21 atoms of K. So now, we want moles or we want particles? Check it, everybody. We want moles or we want particles?
moles.
So we know 1 mole of K is equals to how many particles? Everybody, 6.022 into 10 power 23 atoms of K. Do you remember before I have written up and now I am writing down? Yes, everybody? Yes or no? Before question I written mole is down, but now I am writing mole is up. Why, guys? Anybody can tell? According to the question, we have to write it. Now, atoms of K should get cancelled. Yes or no?
Yes, sir.
When they will cancel? When they are in division only. Same way here. Before, moles should get cancelled. That is why I have written moles down. But now atoms of it should get cancelled. That is why atoms I am writing down. But statement is same. 1 mole of any substance contains how many particles? 1 mole of any substance contains how many particles? Avogadro number of particles. That's all. So now everything will get cancelled. So which is equals to, if you solve. So what is